So welcome to the best practices training session for everybody who's using the greenhouses and the growth chamber here at the Biotech Support Facility in Reitmeyer Hall. Oh, come on. There we go. So if you don't know who I am, I'm Joan Leonard. I'm the greenhouse coordinator for the Biological Sciences greenhouse over on main campus. And then I'm also overseeing things here as far as the renovations and implementation of best practices here at Reitmeyer and the Biotech Facility. If you don't know Gary Posey, you should. He's going to be our day-to-day manager at the greenhouses here and the growth chambers. So why are we doing this? Well, we want to reduce or possibly eliminate pest and disease issues and improve our plant health. We want to increase the success of our experiments, improve uniformity and repeatability, and abide by all the regulations set forth by NIH, APHIS, EPA, ODA, and other assorted federal laws. So we have some to-dos and some to-don'ts. So we're going to go through the growing to-dos. Use clean, sterile pots and trays. Label. We're going to talk about this later too. Label, label, label. We need to know whose stuff belongs to who. If we have a problem with it, we want to be able to go back to that person. So it's not just enough to have your color coded in there. We want to have your name on there. That's one of the things we'll probably talk about at our question and answer session later today. If we don't know who it belongs to us and we discard it. So that's effective immediately. Surface sterilize your seeds. 10% bleach, 10 minutes. That's because some disease issues can be residual on the seed coat, and you're just passing on to that next generation if you plant seed that hasn't been sterilized. You're probably doing that anyhow if you're growing anything on auger, so just use that same practice. Follow our order of entry, and we'll be talking about what that order of entry is in a little bit. Water and fertilize properly, and I'll be hammering this down to everybody about not overwatering and what that leads to. Lab coats. Starting next Monday, Gary's going to be hanging lab coats on all the growth chambers. And so when you're working in that growth chamber, you're going to wear that lab coat. And then know how to ID pests and on INSV, which is a disease problem affecting Arabidopsis. So proper watering. Number one, Arabidopsis is not aquatic. We see Arabidopsis in trays full of water for days, sometimes weeks on end, and guess what? It's not happy, and you're going to have pest and disease problems because Arabidopsis is not aquatic. So overwatering is the #1 cause of plant diseases, pest problems, and death. So you're either watering maybe too much or maybe too often, combination of both. Overwatering will weaken the roots and allows the pests and diseases an opportunity to get in and take hold. So never leave your plants standing in a tray of water longer than 10 minutes. After 10 minutes, it's going to suck up as much water as it's going to suck up. And that soil is already saturated. It's not going to take up any more. So any excess water after that will start to break down your roots. Reduces the amount of oxygen that's in there. Next, algae growing on the soil surface is an indication that you've been overwatering, that has not been drying out, because algae can't grow where there's no water available. And so if that soil surface is staying constantly moist, you're going to have algae growing on the top of it. And that's going to be food for fungus, gnats, and other pesties. And plants found standing in trays of water, as we go through the chambers and we find them there, we're going to start poking holes in this. So they're going to drain one way or another. You drain them, or we help you drain them. All right, so watering, how much, the quantity. So when you're nesting your flats together, a lot of folks tend to do that. They'll put a whole flat inside of a no-hole flat, and your water can get trapped in that space between the two flats, and that's where algae can form, and that's where your fungus gnats can get into. So when we say empty the trays, we need, all the trays need to be emptied out. So watch for that trapped water. If possible, only water the cells in the tray that need to be watered. Sometimes you'll find that there's a slope in the chamber, and one end stays wet, the other end stays dry. So only water the ones that need to be watered. Know what dry is. Feel the soil. If you don't know by just looking at it, feel the soil to be able to tell whether or not the plant is wet or dry. If you're bottom watering with a whole flat, only add enough to cover the bottom and see how quickly that gets taken up. And then if it's taken up within a few minutes, then your plants you know, took up as much as they can. If the water just stands there, your plants weren't even thirsty to begin with. Again, after 10 minutes, you're going to pour off your excess water and never leave them standing in the water longer than 30 minutes. After that, you start to get oxygen deprivation to the roots. How often are you going to water? Well, you should be checking them every day, but only watering as they need to be watered. So I know a lot of people have schedules Monday, Wednesday, Friday, and on Friday we water extra heavy because we want to make sure it gets through the weekend. Well, plants are individuals. They need to be treated like individuals. So rather than watering everything all at once just to make sure it makes it through the weekend, just checking water as needed is the best rule. Avoid watering insurance. That's your extra heavy Friday watering, or holiday watering too. So if this is the kind of thing, you know, hire a student to come in and check on things over the weekend. At our facility, we have somebody there 365. There's somebody there every single day to come in and check on the plants. Here at this facility, everybody's kind of left to themselves to do whatever, but you should have the same policy. Somebody should be checking on those plants. If they're that important to your research, then somebody should be there every day. These are living organisms. You've chosen to work with a living organism. They have daily needs. You wouldn't leave your dog for the weekend and not have somebody walk them, and well, you'd have a mess when you got home actually if you did. So that's why sometimes you come in Monday and you find out you have a mess. So having a Friday on watering on Friday will get you through the weekend, but it probably will get you even through the whole next week. So don't be coming in on Friday, do a heavy watering, and then coming back in on Monday doing a heavy watering. Check the plants. Do they actually need the water? Rarely do we see plants that are underwatered. And if they are underwatered, it's usually because the project is over, they've been abandoned, forgotten about. So, but this is easily fixed. Overwatering can't be fixed. There's no way to take that extra water out. We can always add water. So once you're done with your project, you want to do some proper disposal. So as you're transporting, I think pretty much this is the NIH guidelines, probably also in the APHIS guidelines. If you're transporting plants from one area to another, they always need to be covered and contained if they're GMO. So make sure that you're doing that. You need to promptly dispose of any unnecessary plants back in the steam carts that are back by the dock area, and make sure you're not putting any plastics or stakes into them. Also, make sure you're keeping the adjacent growing areas clean, especially in room 100. That's a potting room. We see a lot of dirty pots, debris sitting back there. Those are just sources of pest infestations. So we want to clean that room up, and that's going to be a clean room. And keep, well, we're going to talk about how to handle dirty pots here soon. But we want to keep any of our planting areas clean and free of any kind of pest and debris. If you notice any kind of infestations, please talk to Gary. He's going to be here day to day, or myself, but he would be the best person to talk to. If you're noticing something happen with disease, pest problems, we want to attack it as soon as possible. He might not be checking on your plants every day like you are. So whoever is your person that's in there working with plants every day is going to be seeing them, and they're going to notice something hopefully prior than we would. And if we have INSB infected plants, those need to be discarded immediately. Very important, make sure that everyone who works in your lab, I don't care if it's an undergraduate who's only there for 2 weeks, up through postdocs, everybody in your lab needs to be educated on all these procedures so everybody is following them. If somebody starts to mess up, then it can start messing everybody up. So handling don'ts, make sure you're closing the chamber doors as much as possible and not just leaving them hang open. Anything that's breezing down the hallway through the ventilation system can get blown into or sucked into a chamber. Also, make sure you're not moving any plants from one chamber or room to another. We're going to keep everything in the same chamber continually. And this I like to stress, don't put all your eggs in one basket. If you have something especially valuable, try to stagger your germination dates and your germination locations, because if a chamber goes down, we have some kind of mechanical breakdown, and everything that you had of most value is in one spot, not much we can do to help you. But if you have it staggered out a little bit, then at least you have some hope in the remaining. And guess what? Plants do this naturally. They have staggered germination rates out in nature, and that's specifically why. So they have a higher success rate. So we're going to go quickly through some pests and what we're doing to take care of them. So thrips is probably one of the most common pest problems that you're finding in the chambers in the greenhouse over here. These are plant tissue eaters. They'll get in there and start sucking. They pupate down on the soil. They also carry INSV, which is impatiens necrotic spot virus. And if your plants get that, there is no cure. They have to be destroyed. That's the only way to cure it, to get rid of it. So we want to make sure that we are controlling our thrips so we don't have INSV problems. Fungus gnats is probably our number 2 plant pest. And not so much, you'll see the adult flying around, and that's pesky enough, but down in the soil are those larvae. Those are root eaters. So they're eating the roots of your plant. Suddenly you have a dead plant. What happened? Well, the roots have all been eaten off by the thrips larvae, or the fungus gnat larvae. So again, these guys like wet soil. So by keeping your soil not saturated, then they're going to be a little slower in their life cycling. Another major problem, especially with the Arabidopsis powdery mildew, we see that coming in. That's crowded conditions, poor air circulation, low light. Guess what? That's what a growth chamber is. So we're going to try and get a handle on that. The spores are short-lived and they need to have moisture to germinate. So again, moisture is another issue. We're going to try and keep our moisture levels down so we don't have, especially when you start sleeving things, the moisture really builds up there. So by keeping our moisture levels down, we're hoping to control a lot of the powdery mildew issues. So what does INSV look like in Arabidopsis? Just random dead leaves. You see at the top. You'll start to see a yellow midroom, purpling of leaves, and then just random death within the flats. Some of these, like 18-hour days or longer, or definitely if you go into 24-hour days, you're going to start to see purpling of the leaves, and that's another reaction that's causing that. But that's what we look for. We do have INSV test kits, so if we start to suspect any INSV infestation, then we'll do a test, and if we positively identify, then the plants that are affected will be immediately disposed of. We can't chance that you're going to spread that to somewhere else. But by thrips.
Only by thrips.
Only by thrips, yes. So, let me rephrase that. Thrips is the primary, but the virus can live on the seed coat. So in your seed handling, if you're not doing your seed sterilizations, then the virus can be transmitted with the seed as well.
But
so
the fungus gnats or airborne doesn't occur.
They're not vectors for the INSV, just the thrips are. So we're hoping that just by controlling our thrips problems, we're going to control any INSV problems, and that should be INSV should not even be a concern after that. We have done some random testing and not found any INSV infections yet. So
I was just saying that could happen for a lot of other reasons. I mean,
exactly. Oh yeah, exactly.
Exactly the most diagnostic, just those 4.
Yes, but when we start to see some of these things, that's when we'll start testing for INSV.
What's the nature of the test?
It's just a little assay.
I see.
So they're like already set up packets, and we just sample a piece of tissue in the buffer, and then it's very much, it has a little dipstick like a pregnancy test. Yeah. Mm-hmm. So it's within 5 minutes, we'll find out. So if we do find things with INSV, those plants are going to be immediately removed and destroyed. No new plants are going to be permitted in an infected space. So if we find a chamber that had infected plants, remove the infected ones that we know of that tested positive. Any remaining plants can stay there, but no new plants will go in. Any plant material removed from that for the duration will have to be bagged before it's removed. And then anybody who's working in an INSV infected space, after you've worked in that space, you have to exit the building. You just can't come back until the next day. We want to make sure you go home, you take a shower, watch a movie, go do something else, but we want to make sure that you're not actually going to be transmitting any of that.
What was the point of that? Is it not mechanically transmissible?
You could be carrying thrips on you that are carrying the INSV. So the thrips are very small, they will jump on your clothing, you are wearing your clothing, will go into the next chamber, and they jump off of you onto the plants that are over there. So yeah, it's as far as, you know, so go home, take a shower, change
Well,
clothes.
practically speaking, you're not talking about exiting all of Reitmeyer, I hope. You're talking about leaving the greenhouse area.
And don't go into any place that has plants.
Right. Okay.
But I would be concerned about hanging out, because I know that a lot of people have plants in their labs. And so you walk from the chamber
But if
into
you
your
don't have
lab.
any plants in your lab or in your office,
Yeah,
you
yeah.
won't be able to go back into our lab.
Yes, but you cannot go back into any other growing space. We would just like you to have that for at the end of the day and then just leave. But hopefully we won't have INSV problems, and this will be,
So have you had this on main campus? Or where have you
yes,
seen this?
yes. So these all started out at RNF. A couple of years ago, they came to me. We were trying to figure out what this mystery problem we were having, and they tested positive for INSV. So we had to rogue out the plants that were infected and then set up protocols to make sure that those thrips were being managed, but also that nobody was, you know, carrying them around with them as they went from visiting space to space.
Currently?
0. Yep, 0 thrips, 0 INSV. So that we're releasing a lot of beneficials to control our pest populations. I know randomly before there was some mysterious pesticide bottle that people would spray whenever they felt like the pest problems were getting too large for them. So we're aggressively going through doing weekly counts of what the pest problems are in each space, and then we're making decisions on what beneficials we'll be using. These are some critters that you might see running around on your plants. The mite at the top that's kind of orangey is Neoselius cucumerus, and it eats thrips larvae. Down at the bottom on the left-hand side is Hypoaspis miles. That's a soil-dwelling mite, and that will eat both thrips pupae and fungus gnat larvae. And the thrips pupate in the soil, so that's why they're soil-dwelling mites. And then on the right here, you'll see a bit bigger bug. These mites are very small. I have to look at them under the scope, or if I put them on a white sheet of paper, kind of look for a speck of dust that moves. That's the only way I can really see them. But the beetle down here, the rove beetle, is much larger. You will see it crawling around looking for food. And again, it's going to be down in the soil, and it's looking also for the thrips pupae and the fungus gnat larvae.
So if you do release these into a chamber, will there be a notification for that chamber? That
All chambers will have them released in them, and we already released them into
Okay.
most of them. All chambers have them. Yeah, all chambers has.
For all these species.
Mhm.
So they will be there essentially continuously. So
Yes.
we should expect that there could be insects like these
Yes.
at all times.
If you're concerned,
No, I'm not concerned. I just want to know if
Yeah.
someone goes in there and they see insects and they're not familiar with thrips in specific, they may just go on to alarm mode.
yes,
Whereas
exactly.
it might
That's
be
why we're
one of
trying
those-
to let you know what you're looking at.
Yeah, I understand that.
Mhm.
Like undergraduates come to the lab.
And that's why
they're
you're going
not
to show this to your
Okay.
undergraduates, so
But
they
how-
won't. So it is really critical for us to have a break in the life cycle of the thrips in order to really get complete control of it. So we're going to enforce a chamber clean out approximately every 3 months, and that's typically enough time for folks to get a life cycle out of their crop. So all the chambers that are in Reitmeyer and the biotech support facility are going to be common shared space, except for the ones that are owned by AVRC, and they will all enter into the rotation. I think we have at least half, if not more, of the chambers are currently in the rotation. There's 1 chamber left over in the greenhouse and 4 chambers left over here. So we're getting pretty close to getting everything into the rotation. If you have special requirements that you have to have special temps, special day lengths, special something that is not fitting into the short day, the long day, chambers that we currently are going to have set up, then please talk to Gary and make arrangements with him. I need a 24-hour day, I need an 18-hour day, I need a 30C, I need a 10C, whatever it is, and we'll try and schedule it in. But it's going to take some scheduling time, so please make sure you're trying to plan ahead. You just can't show up and say, tomorrow I need, because it's going to be harder for us to come up with that type of space on short notice. There's no longer going to be any continuous cycling. So one chamber will not be, it's always going to have a
So as we implement the rotation, and we'll need everyone to be patient,
The space that is available in clean chambers can be limited as we wait for the plants that are in the dirty chambers to finish up. And so we're asking everybody to help us by removing any dead or drying plants as soon as possible so we can move right into getting all of our chambers clean. Next, we're going to talk a little bit more detail about the space rotation and how that will exactly work. Each of the growth spaces, whether it's a chamber or room, is going to have 6 weeks for planting. That 6-week window will mean that as long as there's space available and there's no INSV detected, then we will have places for folks to plant. Once the place fills up, or if we detect INSV, then we will actually close that space. At the end of the 6 weeks, that chamber will go into a maturation window, which will be approximately 6 to 7 weeks, allowing, typically it's Arabidopsis, to fully mature. At the end of that time, we'll then have a clean out. That will be a 4-day clean out, no plants in there. All the plants need to be harvested by the last date. 4 days of heat treatment. Our staff will do that, clean it out, heat treat it, and then it will open again after 4 days for a new planting window. You'll see that spaces are staggered so that we almost always will have open planting windows in the various day lengths and temperature regimes that are required by most of the research. As I said before, if you have something that is a special requirement for either temperature, light levels, day length, you'll need to coordinate that with Gary so that we can schedule a space for that to happen. Very important that we aren't moving plants in between different chambers. So if there are plants in one space, they are not going to be permitted to move to another space. So when you're planting in one of these planting windows, you need to make sure that your plants will be able to be mature and harvested by the last date. All of these dates are going to be posted on each chamber as far as the last date to plant as well as the last date to harvest. These will be posted on each chamber, and we'll also have it on the website, and you'll be able to check at all times and see what's scheduled for each of those spaces. I think that's all.